Okay, welcome to week 11 of PM272. This is our last lecture of the module. I really hope you've enjoyed. And if you have enjoyed this module, I run a related course in year 3, PM365, Introduction to Machine Learning using R. If you've enjoyed this module, or if you haven't, can you please provide feedback via the end of module survey? I'd be very grateful. Any improvements that I could make, anything that you did like that I might want to keep, I'd be very grateful for that if you could. So this week, it's all about creating web apps or websites with R, which you can do if you didn't know. And what I mean by a web app is perhaps something like this. We were looking at the coronavirus data from the government website back in week 5 or 6. And they've got these handy dashboards which summarize coronavirus data. They are updated daily. So this is live data, if you like. And you can interact with this, as well as having lots of nice graphs. You can interact with the data. You can perhaps view how COVID is progressing in your area. We can look at summaries of cases if we wanted to. So here's some, there we go. So these are daily cases of COVID in the UK. And you can manipulate or interact with these graphs just like that by a click of a button. And again, we can go down, look at cases by date reported, cases by nation. And you see how we get these nice interactive feedback from our graphs. Well, we want to see if we can build a dashboard like this in R. It'll be quite simple, but you know, we could build up to something like this if we wanted to. So the way we do this in R, well, we're used to creating these .r files, but today we're going to create something called a Shiny file. And the way you do this is you go New File and then Shiny Web App. At this point, if you don't have Shiny installed, you should be prompted, or R will prompt you or ask you, would you like to install Shiny? So you can just say yes. So we'll just create a demo just to show you. And you get two choices. You can put this all in one file. I would recommend doing it in 2 separate files. One file is going to be a user interface where we define buttons and things like that. And we're going to have a server file which handles all the data for us. So I'm going to create these 2 files now, UI.r and server.r. And when you do this, it creates this in your directory. So we just created this directory now, demo app. And as you can see, we have our 2 files, UI and server. And it gives you a nice example straight off the bat. So we're just going to run this and see what it looks like and try and relate this back to the code that's in the UI and the server code. So you just click on Run App, and then you'll get this new window where your new app opens up. And this is really simple. And all it allows you to do is just to change the number of bins in this histogram. What we mean by that, well, I'll show you. If we move the slider, we can interact with our graph in this way. There's a few things to note. We have things like our title of our app. We have this slider input. And then we have a graph that's being produced. And if we just take a look at the code to see where we can relate this back to, well, we've got our UI, our user interface code, and it's using our Shiny library Shiny. And what we do is we want to produce a UI or user interface, and we define this with a function called Shiny UI, and we're going to create a fluid page. There are loads of examples on Shiny. You can literally copy and paste and just put in your own data, which is what we're actually going to do today for our COVID analysis. So we're going to create a new page, and here's our title panel, and this is our data set. And then here we have a sidebar with a side panel. And inside that is this slider input. So this is where we could move this slider about. If we just have a look at how it's defined, they've got this object, or it says number of bins on there, so we saw that. And there's going to be a variable called bins, which we're going to use later on in our data. And at the moment, the value when you open up the app is set to 30 bins. And you can choose or move this slider between a minimum of 1 bin and 50 bins. So it's pretty simple. We've just defined this slider input, this nice function here. And we define things like the min, max, and the default value when you open up the app. Then the only other part of our app is in the main panel where we want to plot our histogram. So we're going to say plot output, and we're going to plot this variable distplot. So this distplot is going to be defined in the server file, and the server file is going to use this variable bins. So what you need to get to grips with when working with Shiny apps is that variables are going to be passed from the UI to the server and from the server back to the UI. So let's focus on the server, and we'll try and spot this bins variable to see what's going on. So this is our server. Again, we load the Shiny library, and instead of a Shiny UI, we're going to create a Shiny server. And it takes some input. So this is anything that you mess about with buttons on the UI, that's your input, and it's going to produce some output. So the Shiny server defines how you can take variables from the UI into the server. So that's with these arguments called input. And then also how the Shiny server allows you to share objects produced in this file back to the UI. This is output. So that's our Shiny server, defines our inputs and outputs. And we're going to produce this variable, output $distplot. And this is going to contain our histogram. And at this point, there should be some, this is just bog standard code. So inside of our Shiny server object, this is just some code that we're used to, that we've been doing in weeks 1 to 10 so far. We're just defining a data set, our bins, and then finally how to draw a histogram. So I won't cover these really because we know how to plot things like line graphs and histograms and so on. You've just got 3 lines of code which define how to create this histogram. And the important part I want to look at is this input bins here. Usually what you would do is to specify a number, length.out equals 30 or 29, however many bins you want. So you would just, this is called hard coding. You would put the bins in there. So we'd say we want 30, 40, 1, 2, or 3. We would actually put the number in. But this time is going to be defined by a variable, which is our input $bins. So we get this. Let's go back to our UI. Here, we're defining a variable called bins. So in the slider input, we move it to where we want, and wherever it lands on, in this case 30, this bins variable is going to take the value of 30. This gets passed into the server via input, and we access this number by saying input $bins. And remember, wherever the slider lands on, you get the equivalent of bins equals, say, 40, and then you can use this in our input. So this is a variable now. And you're okay with variables. We've covered variables quite a bit in the course, but it's slightly different in this case. We are inheriting a variable from a different file. So this bins variable gets created in UI, but we can use it in our Shiny server. So that's all there is to Shiny files, really. You're just looking at how you can specify a UI, certain buttons or drop-down lists, sliders, how you pass that input to a server, and then you can actually do your normal R work inside the server. And then all you want to do, these 3 lines create a histogram, and we are storing it as a plot using this function called render plot into this variable here. So once we've created the histogram, This sends it back to the UI, this object distplot here. So that's how you get your plot. And there you go. So you can create this off the bat. If you just create a new Shiny file, you can start off with just this easy example to try and get to grips with how Shiny works. What we want to do today is to adapt or create a Shiny Shiny web app, which uses coronavirus data. And let's just take a look at what data we want to use. So if you remember back in week 5, we used the API to pull some coronavirus data down from the server. And you just put in a URL and you parse the file and you end up with some data frame. So I'll just run this and I'll explain how I got it again. Let's just see what this looks like. We can view our data frame. And these files will all be included on Canvas, by the way. So we view our data frame. It looks a bit like this. So we've got a few columns here: date, new cases, deaths. I'm not quite sure what this column is not available, but it's basically, it's because it's by hospital. So this is how many ventilated beds are available. You have to do a hospital level, 100% area level. So we've got some data. And let's just have a look at this URL again to remind ourselves how we got this. So we just put in this URL. This is the API. And we're going to use the HTTR package to do this. You use the URL and you can actually specify parameters in here. So I want area type equals region. So I want to break down a coronavirus by region. And I want these columns. So I want mechanical ventilator beds as a column. I want new cases as a column. I want new deaths as a column. And since we covered this in week 5, they have actually updated how you can do this to make it a bit easier. So before, you would have to go through the API and go through all the documentation. But now, if I can show you, so before we had to go through all this documentation like this. So go through the through the UI here, and look at things that you want to download. Instead of reading all this now, a new page that they've got, which is experimental, as they say, but it seems to work fine for me, is you can actually build our URL off drop-down lists. So again, I can choose how I want my data. I want my COVID breakdown by region. You can specify area names if you want. If you just leave it blank, it will return all of them. And these are the columns I want to choose. Again, I can choose even more, whatever takes your fancy. I'm going to take these. You can specify that you want the latest. So that'll be the day that you download this will either be today's data or yesterday's data, and the output format. So you can download this in CSV format. I think it's still a bit odd for me, but we used JSON before and we've written code to parse JSON, so we're going to use this. The important point is that they've created this link for you. So you can just copy this and paste it into here, which is exactly what I've done. So this is a lot easier now. Instead of you having to sort of feel around in the dark, you can use this nice data download tool, or you can also download this as CSV if you wanted to. Anyway, so this is where I got the data from today that we're going to use. And as I said, we wrote this code, most of this code in week 5, stats in R. So we just use HTTR to pull down this data from the web using this URL. And we just parse this using JSON, parse the JSON object from this, and we end up with a nice file. And one thing I have done is, because mass testing didn't really start until after this date, I've just done a little filter here. So this is the data that we're going to be using today. And what we'd like to do is to plot some interactive graphs. And I'm going to take you through some code to do this. I've created a UI and a server from scratch, and we're going to go through the app. So I'll show it to you first, and then how I created it. So the idea behind this app is that you can plot any column against any other column. So at the moment, the default values are date and new cases by published date. And so these are drop-down lists that you can choose from. You can choose whatever value you like. And also what I've got are some checklists. So I can check, for example, just East Midlands, and it will give me the, on the x-axis, the date and the number of new cases. And I can just add in, so I'd like to compare maybe East Midlands to the east of England, and I can just add in different lines on this graph. So you could check them all. You see how it updates. The graph gets a little busy at this point. So here you've got all regions. And again, if I want to get rid of maybe London, I can just deselect London. And also, maybe we can plot deaths instead of new cases. So again, we just, in the drop down, find our data which we requested. And there's currently two measures, whether you died of COVID 28 days after, how they define a COVID death. So if you've died 28 days after being diagnosed with COVID, this would be a yes, you'd be recorded under this metric. And if you died up to 60 days after getting COVID, you would be recorded in this metric. But it doesn't really matter. We're going to choose one. We'll see what the graph changes for us. So this is quite useful because you could perhaps look at, do the number of cases lead to number of deaths, which is something which might find quite obvious, but you can just plot deaths against cases. So let's have a look, new cases. Again, this looks very busy. Let's see if we can make a bit more sense of this. Maybe we'll just look at East Midlands again. So this plots cases against deaths. So it's quite jumpy. You can probably see that there is a slight trend. So obviously as cases increase, so do deaths. And I think I've got rolling average in here. Yes. So the reason why you see lots of jumps up and down in cases is because of the way cases were recorded over the weekend. So there's a delay in recording COVID cases over the weekend. And you often find that Saturday and Sunday numbers are very low, which is what these low data points are. And suddenly on Monday, retrospectively, these dates are recorded. So on Monday, you have a huge spike again. There's kind of a way you can deal with this. You can take a rolling average. It's not that much better. Maybe we'll do this with dates. Yeah, so there's nothing really happening. Oh, let's do this the other way around. There you go, linear, because you're plotting the same thing. So yeah. So this smooths it out a little bit, and because that they tried to take into account that there are delays in weekend cases. The point being is that what we developed here is a way to interact with the graph quite nicely. So if we think back to our data visualization lecture, you could try and maybe force a way to visualize all of these variables in one go. Maybe with faceted plots, you could have 10 different plots on this page. Here we give the users to choose what they want and by region. So let's take a dive into the code to see how we did this. First off is the UI. So we had two drop-down lists, one to choose the x-axis and one to choose the y-axis, and we also had a checklist to choose the region. And again, I think I just copied the code from our example Shiny app and just changed it about a bit. So instead of a slider, I've got a select input. So this just creates a drop-down list. And our input ID, so this is our variable, we're going to pass a variable called x into our server. It's basically a column on the x-axis. Here's our label. So you can see this here, choose x-axis. And currently, when you open the app, it's set to date. And a shorthand way of populating the choices is just to say names df. So names df will just give you all the column names in the data frame. And there they all are. So that's to choose the x-axis, and I'm going to do the same with the y-axis. I'm going to create a variable called y, which allows you to set the y-axis on our graph. And again, it's almost exactly the same. I set the default, in this case, when you open the app up, to be new cases by published date. And lastly, we have a checkbox. So this allows you to choose different options. So these are actually the value in the data frame. And this is what I want to display on the app. So if we just take a look, it says East Midlands there. That text right there is our first output. And what we're saying is East Midlands is equal to the value of East Midlands in our data frame. So we got it there. So there could be another shorthand way of doing this, but I leave that as an exercise to you. Think of how we populated our choices, column choices here. You could perhaps take all the unique values in one column, but I'll leave that to you. And then lastly, we have a main panel where we want to plot our output. And you can have tabs. So we could have multiple tabs. I'll try and show you an example a bit later. In this case, we're going to have a tab called cases, or whatever you want to call it, and it's just going to plot one. So just before we look at the server code, what variables are we passing into it? We've got this x variable, which stores what we want to plot on the x-axis. We've got this y variable, which stores what we want to plot on the y-axis. And we have this region variable, which stores whatever we've checked in our boxes here. So these three variables get passed on to our server. And we're going to do some stuff with our data. It's really simple, but let's just have a look at our data again. What we can do is we can just save this as a separate file and load it for us. So in our UI, just before, right at the top, we've got source data.r. This is our R file. If I show you the directory, we've got this third data.r file, and all that is pulling down our data for us. So we just do this once at the start, pull down our data, which is here. Do that first, define our UI, and then start passing things to the server. So there's more than just these variables. So we have the X, Y, and region variables, which the server has access to, but it also has access to anything that we specify in this data.r file. So specifically, it has access to this df object, which is our data. So let's look at our server. We are creating a server, and it's got some input and some output. And there's a few libraries that we are going to use. So tidyverse, because we're doing some data manipulation. In fact, because we've loaded them here, technically we don't need to specify them here, but I'll just leave them there. So what are we doing? We're going to create a plot called plot1. And we've seen this plot1 before. Here it is. So this is the variable we're passing back to the UI. We're going to create a plot or graph called plot1. And as I was saying, because we've specified and loaded this data.r file, we already have access to this object called df. Here it is. So our server has access to things immediately. We've got our df. And what we're going to do, just using dplyr or tidyverse language, to select our column X So remember, this comes from our UI. We take input $x. So saying select that, whatever column we chose, select that. Also select the column Y that we chose, and select the column called area name in our data frame. So there we go. So in this app, we're not allowing the users to choose this. It's already loaded. We are hard coding this in. You see the difference? These two are variables that the user can choose, and this is hard coded. This is always going to be part of our app. That's what we decided to do as developers. So we've selected 3 columns, and then to filter by region, remember where we added in London or we took away London, East Midlands, and so on. We then filter. We filter these 3 columns, and we say only keep rows where area name is in whatever we've put in our checkbox. So remember, this looks like this. We've got this variable called region, and we can check different items here. So then we say filter rows. So select chooses columns, filter chooses rows. So we filter rows with the area name, only keep them if the area name is equal to the input that we've put in our checkbox. So, you know, we've only selected East Midlands. Input.region will only be rows for East Midlands. So we've done a bit of data manipulation. We stored it into a new object because we don't want to overwrite our original. And if you want to do a little sanity check in Shiny to see what you've track your progress, if you like, you can say print head. So in this case, you want to get the first 6 rows of our new object. If you wrap it in a print thing, it will output it in the console while you run the app, and I'll show you that in a minute. And this is our graph. So this is the rest of the server. So we are going to take our new object df2. We're going to pipe it into our ggplot function. And we are going to define some aesthetics. Now, this is really important. This gave me a lot of grief when I was writing this lecture. Usually, we'll just use AES. And then you could say X equals maybe date, Y equals new cases published by date. But this object here is just a string. And this took me a while to figure out. So what we need actually is AES string. And this allows ggplot to just take a string instead of a column name. This took me a while to get going. But anyway, what we're doing, we're saying that the x-axis is our x input, and y-axis is a y input. We're going to create a line plot, and we're going to group these by area name of different colors. So again, just to remember what that is. So we've got 2 regions, we've got 2 lines, each different color. And remember, whenever you do this, you always need to create a factor. So what we're doing there is we're taking these 3 columns, one of them is area, and we're turning them into a factor. Okay, so we define our X and Y axes. We've defined what our lines are going to look like. They're going to be grouped by area name. And also we're going to put points in as well. So what I mean by this is we've got our lines between our points. So there's 2 layers to this graph. If you turn the dots off, you just have the line, and vice versa. Exactly the same aesthetics arguments. And the name of the x-axis is just going to be the column that we chose for X, and similarly for Y. And here's our title. So that's it, really. We've created this plot, and we can choose the X and Y axes. And it saves it in this plot1 object. And this is our output argument, so they match up. And then we use this plot1 here. There's a bit to get your head around, but you'll find that actually really useful because users can do whatever they like. They can just, I want to plot maybe new cases against the rate or whatever you like. And there's loads of columns you could have chosen from. You could have included any of these in your download data. And so this is a web app. So you can open this in the browser. So this is our app already open, and it will open in Chrome for us, and it looks like this. So at the moment, this is just running off my local machine. It actually looks a lot nicer when I'm running this in Chrome. So there we go. It behaves exactly as we would like it to. And you can actually create a website, or you can host this if you like, for free via shiny.io. So if I just show you a few examples of this. These are apps that people have created. We can look at a few, and some of them are really, really complicated. So this looks like a fully blown website. So believe it or not, this is all created in R. And you can actually host these for free. So I found a really cool COVID app. Let's reload this. And you can host your apps on shiny.io. This to reload. There we go. Maybe I'll take you through it first, and we'll come back to this. So if you want to publish this, you can do this here. And you'll get prompted to install a few packages to help you do this. There we go, installing it for us. While that's loading, let's see. Here we go, this is back online. This is a really cool, again, this is created in Shiny, R Shiny. This is funded by the Trafford Council. So you can just select different areas and look at nice things about COVID. So you can see how things have changed just in the Medway local authority. You can just switch down and you can create these nice maps. So we haven't really covered maps in R, but you can create maps in R. And this just plots. You can see that the size of the dot indicates the size of the outbreak of COVID, if you like. So, things can get really complicated. You can, create websites like this, and eventually you can create stuff a bit like the government website have done. So again, you can absolutely create websites like this using R Shiny, just to see if we can get on to publishing our app. So the libraries have installed, and here we go. So that you can host your app in a few ways. So we're going to do this via shiny.io. And then publish it. So let's have a look. I'm going to log in with my GitHub account. There we go. So I've already got one application that I host on shiny.io, and let's just publish this app. Oh, okay. Click your name, then choose tokens. Fine. Okay. So we copy this. There we go. Oh, issue. What have we got wrong? There we go. did work. So here we go. It's publishing. It's taken all of our files that we've used. I don't know why we're getting this artifact here. We'll just publish this. Maybe we'll call it PM272. So the stipulation is, as long as you don't have data which is over 1 gigabyte, you can host your apps for free. Obviously, we don't really host much data because we're just pulling this down from the COVID website. So actually, just show you, I made a slight error. What you have to do, instead of copying this token, you show this. Click on show. Copy this to the clipboard. There we go. And then we can put that in here. I didn't want to copy that. Let's do it manually. There we go. Maybe I'll just leave that to you guys. I did this a while back with my old application. But anyway, you can host these on Shiny.io. As I said, you can go through and see a lot of apps that other people have created. So again, things like this. So don't let web development put you off. You can do it in R. I think this person is even, you can order stuff and send it to you via R. So that's great. So, this is just a really basic introduction to web apps in R. It all revolves around the Shiny infrastructure in R. And as I said, you can get some quite complicated apps using, we've seen stuff on COVID, creating maps and so on. So, just have a play about. These two files, actually, and the data file, these 3 files are up on Canvas. So you can run this app how you like. And maybe you can get around to publishing your own app on Shiny.io. Okay, so thanks very much. And have a good Christmas. And don't forget, your assignment is due on the 6th of January. All the best. Cheers.